There are 4 types of metrics in Prometheus, similar to data types that Prometheus can understand: counters, gauges, histograms, and summaries. Each one serves a different purpose, and understanding them is crucial for setting up effective monitoring. Let's start with counters. A counter is a metric that can only increase or reset to 0. It's perfect for tracking things that only go up, like the number of HTTP requests your server receives. Think of a counter like the odometer in your car. It only goes up as you drive more miles. Let's take a detailed look at this metric to understand it better. A counter is used to track the total number of HTTP requests received by a server. At 12 o'clock, the value is 150. By 12:01, it increases to 200, and by 12:02, it reaches 250. The value increases over time as more HTTP requests are received. It only goes up or resets to 0. A reset to 0 happens whenever the server we are collecting metrics from restarts or when the exporter restarts. Here are a few use cases for counters: the total number of errors or requests, the number of processed jobs, or any event that accumulates over time. Next up, we have gauges. Unlike counters, gauges can go up or down. They're used for measuring values that can change in both directions, like current memory usage or the temperature of a server. A great real-life analogy for a gauge is the speedometer on a bike. When you rev the bike, the needle goes up, and when you slow down, the needle drops. Let's see how we can use this metric to monitor memory_usage_bytes. This metric is used to monitor the current memory usage of a server. For example, at 12 o'clock, memory usage might be at 500 megabytes. It then increases to 520 megabytes, and later decreases to 480 megabytes. The value fluctuates up and down as memory is used and freed. It reflects the current state, which can increase, decrease, or stay the same. That's why we use a gauge to monitor this metric. We have to decide which metric to use. If we chose a counter here, it would get stuck at 520 megabytes utilization, and you wouldn't be able to see 480 megabytes, because counters never decrease. Here are a few use cases for gauges: resource usage like CPU, memory, or disk space, the number of active users or sessions, or environmental factors like temperature. Moving on to histograms. A histogram measures the distribution of values over a set of buckets. You can think of these buckets as predefined ranges or intervals that group similar values together. It helps to understand the spread or range of data. To illustrate this, imagine you're timing how long people take to complete a task. Some are fast and some are slow. A histogram groups people into buckets based on how fast or slow they finish the task, showing you how the response times are distributed. It's particularly useful for tracking the duration of requests, response sizes, or any metric where the distribution matters. Let's look at an example to understand it better. This metric measures the distribution of API response times across different buckets. Here we have data from between 12 o'clock and 12:01. The number of requests completed in under 0.5 seconds increased from 50 to 70. At the same interval, we also see several requests completed between 0.5 and 1 second, and a few requests completed between 1 and 2 seconds. This is how it looks as a graph in Grafana, with response time buckets on the x-axis and the number of requests on the y-axis. From this, we can understand how many requests were completed within each specified time frame, which are called buckets. We can also see the increase in requests from 50 to 70 that were completed within 0.5 seconds. This is a good indicator of performance improvement. This allows you to understand not just the average response time, but the full distribution of request times, helping you spot outliers and trends. You can create buckets with other values too, like kilometers per hour or response bytes. The key thing to remember is that buckets are not only meant to work with seconds. Use cases for histograms include tracking request duration or latency, monitoring data sizes like payloads, and understanding the distribution of response times. Finally, we have summaries. Summaries are similar to histograms but with a key difference, which we'll understand better with an example. They calculate configurable quantiles, which are essentially percentiles, such as the 95th or 99th percentile. This means you can see, for example, that 95% of your requests are completed in under 2 seconds. Think of a summary like the grading system for an exam. You might not care about the average score, but instead want to know the score at the 90th percentile. We'll understand this with an example. Here we have a metric called http_request_duration_seconds. It measures the latency of HTTP requests. The 50th percentile, also known as the median, is the value below which 50% of the observations fall. It represents the middle point of the data. If you look here, at 12 hours, 50% of the HTTP requests had a duration of 0.6 seconds or less. This means the remaining 50% had a duration longer than this. At 12 hours and 1 minute, 50% of the HTTP requests had a duration of 0.5 seconds or less. The 95th percentile is the value below which 95% of the observations fall. It's useful for understanding the upper bounds of performance. At 12 hours, 95% of the HTTP requests had a duration of 1.2 seconds or less. At 12 hours and 1 minute, 95% of the HTTP requests had a duration of 1 second or less. The remaining 5% of the requests had durations greater than 1.2 seconds and 1 second. The same concept applies to the 99th percentile. This is how it looks as a graph, in Grafana, with response time buckets on the y-axis and the percentiles on x-axis. Use cases for summaries are measuring request latency in precise percentiles, tracking performance metrics, and identifying trends over time. That's all for this video. I hope you liked it, and I'll see you in the next video.